So those of you who were hoping that balancing equation would go away, I've got bad news for you. It's still here. Okay, but maybe, just maybe, like I said last week, balancing equation is a lot like riding a bicycle. At first, it feels like you're never, ever, ever going to ride the bike, and then something just kind of clicks, and then all of a sudden, look at you riding up and down the hills of Tennessee. So we're going to add one little piece of details to a balanced equation to tell us even more information, and that is the phase notation. Phase notation. What other pieces of information can be used with a balanced equation? It's phase. It's happy phase. It's sad phase. It's constipated phase. Okay, maybe not it's constipated phase. Or it's happy phase, or sad phase, or anything. Let's go through them. If you are a solid, we would abbreviate it S for solid. If you're a liquid, we would put a little L by you. If you're a gas, we would put a little G by you. And if you are dissolved in water, we would put AQ. Now, this is the confusing one. What does it mean to dissolve in water? Well, look at this diagram. So you have some salt just sitting there, ready to be sprinkled on some French fries. Then you take that pile of salt and add it to water, and it disappears. And you're thinking, whoa, according to the law of conservation of matter, it can't disappear. And you're right. Not that you would ever think those thoughts, but you're right. The law of conservation of matter says that matter cannot disappear, cannot be created, cannot be destroyed. What is actually happening is that those salt crystals are dispersing in water into their ion form, so much so that you can't even see them anymore. They're there, but you can't see them anymore. When something dissolves in water, we abbreviate it by the letters AQ, aqueous, which means in water. That's all it means, in water. So how do you know if something is AQ or not? Two questions. Is the reaction taking place in water? Usually you're going to see words like solution. If it is, then it's probably AQ. But to know for sure, all you have to do is look on the chart that I gave you. Should be a chart that kind of looks like that. It has most of the polyatomic ions, which we call Costco ions, and it has most of the Walmart ions that you will be dealing with. On the left side, you will encounter the positives. These are the ones listed first. Oops. These are the ones usually listed first in a chemical formula. And then on the top are the negatives, which are usually listed last. All you have to do is look. If I say, hey, aluminum hydroxide, you need two piggies, two fingers. Okay, so put one finger on the aluminum and put the other finger on hydroxide, which is OH, and then you move your piggies until they both intersect. And what the chart tells you is what is going to happen. Either it's going to be solid, which means it will not dissolve in water, or it's AQ, which means it does dissolve in water. You don't have to write that down on your chart. Basically, if the first element is not on that chart, it's AQ. All the alkalis, for example, hydrogen, lithium, sodium, that first column, they're not on that chart because they are all AQ. So if the first element is not on this list, it's AQ. AQ. Any questions? So let's practice using this chart. You drop crystals from the ionic compounds into water. Will they dissolve? Write down S if they do not dissolve. Write down AQ if they do. All right. Destiny. It is your destiny to get this one right. So let's find AG. AG is right here. So let's find CL. CL is right here. So let's move our piggy. Destiny. What is it? S for solid. Yes. Genesis. Na is not on the left. It's not on this chart. Na is not on this chart. How are we supposed to know this if it's not on the chart? Well, it's easy. If it's not in the chart, it's dissolving. It's AQ. Good job, Genesis. Iron 3 phosphate. Alex. There are two irons. Which one should this be? Should this be iron 2 or iron 3? Well, I told you what it was. It's iron 3. So, iron 3, phosphate, what's it going to be, bud? Last one. S. Good job. And Byron, copper 2 chloride. Copper 2 is right here. Chloride is right here. AQ. All right, let's practice. What do we call these watery reactions where solids are formed? Precipitation reaction. Wait a second. Precipitation, that's like when it rains, right? Yeah, actually, it kind of is. So let me explain to you why we call it precipitation reactions. What are these yellow, beautiful yellow crystals? What do they appear to be doing? Raining down, right? Raining down. So that's why we call it a precipitation reaction, because it looks like the crystals are raining. What's really neat about this is that on top you have the lead clear. On the bottom you have iodide clear. And together, when they come together, what do they form? They form these yellow crystals that are raining down. So it is called a precipitation reaction. A precipitation reaction. All right, let's do these. Let's once again review how to do this. Any volunteers? All right, Maximus, thank you for volunteering. Oh yeah. How many NAs? How many NAs? All right, if you still don't understand this, why don't you give this a go? Why don't you focus, clear your mind, and look at what I do and look at how I do it along with your classmates. Now, OH is a group. So how many OH is there? One. How many OH is there? Okay, the distributive property is the key to this whole thing. You've got to understand distributive property. What happens is the number outside gets distributed throughout. So how many hydroxides? 3. So we're going to have to distribute 3 throughout. So we need 3 hydroxides on the left. So what number do you multiply the whole thing by in order to get 3? All right, now here's the deal about these things. Yes, we just fixed hydroxide because 3 times 1 is 3. But you can't just say the 3 is just there for hydroxide. No, 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 no. That's like by putting a 3 there, you're saying you have 3 NAs and 3 OHs. So guess what we just did? We just messed up the NAs. Because what did we say we have on this side? 1. So we now have 3 NAs on the left, 1 on the right. What must you multiply the right by in order to get the same number? 3. How many irons? NO3 is a unit. It is a Costco item. How many of those NO3s do we have? 3. How many NO3s do we have on this side once you distribute through? You have 3 ones. So for a total of 3. See, when we fixed the Na, we actually ended up fixing the hydroxide. So very quickly, let's go through, make sure that we've got this right. Distribute. How many NAs? How many OHs? I'm sorry, how many NAs? 3. How many NAs? How many OHs? How many OHs? How many irons? How many irons? How many NO3s? How many NO3s? Good job. All right, look on your chart. Find Na on the left. Find Na on the left. Do you see Na on the left? Maximus? No. See again, the chart that I gave you. The solubility chart. You're on the wrong, there you go. Do you see Na on the left? Okay, so what must it be? All right, do you see iron? There's 2 irons. Which iron must this be? Reverse crisscross, it must be iron 3. So iron 3, find iron 3 on the left. And go until you get to hydroxide. What does it say? All right, we're done. Let's do another one. Who on this side of the room would like to volunteer? I'm going to volunteer you if you don't. Thank you, Matthew. How many BAs? How many BAs? How many NO3s? How many NO3s? Okay, folks, listen to what I'm saying. How many NO3s? Those of you who are saying 3, where are you getting the other 3? I said NO3. You don't have 3 NO3s, you have 3 O's. In NO3. You see? NO3 is a Costco item. It's a package deal. You have 1 box containing 1 N and 3 O's. So how many boxes of NO3 do you have? 1. We got a problem. You have 2 on the left, only 1 on the right. What do we multiply the whole thing by in order to have 2? How many K's? How many K's? What? Okay, you have 1 KNO3 that we're multiplying by 2. 2. How many SO4s? How many SO4s? Good job. Let's go back and check. How many BAs? How many BAs? How many NO3s? How many NO3s? How many Ks? How many Ks? How many SO4s? How many SO4s? All right, so use your piggies. What is BaSO4? What about KNO3? Why? There, that's why it's AQ. If it's not there, it's AQ. This side of the room, volunteers, before I volunteer you. Thank you, Daylin. How many CUs? How many CUs? How many CLs? Correct. There are 2. How many CLs? Correct. There are 2. How many PVs? How many PVs? How many NO3s? How many NO3s? All right. It's all balanced. Look on your chart. Find CuNO3 too. Okay, folks, let me give you a little shortcut. Look at all of NO3s. What do all NO3s come out to be? Okay, so all NO3s are AQ. So if you ever see AQ, bam. PBCl. PBCl. Good job, Daylin. This side of the room. Austin, thank you for volunteering. Actually, thank you to Matthew for volunteering. How many ALs? How many ALs? How many CUs? How many CUs? Ooh. How many CLs? How many CLs? Okay. Let's go through this 3-2 thing. Is there any way that you can make an even number like 2 to become odd? Is there any way you can multiply 2 by something to make it into an odd number? No. You learned that in elementary school. Is there any way that you can multiply an odd number in order to get an even number? Yes. The easiest number to do is 2. Okay, so there's no way that we can ever balance a 2 with a 3. What are we going to have to do to that 3? Multiplied by 2. And that gives you 2 3s. 2 3s is, what must we multiply this 2 by in order to get 6? Austin? 3. All right, we fixed the chlorines. 3 times 2 is? 2 times 3 is? All right. Now, what I've always tried to teach you is to always go back and check, because sometimes in order to fix something, we may screw something up. How many ALs? How many ALs? How many of those ones do you have? Folks, don't forget distributive property. It's 2 times AL. 2 times 1 is, so what must you multiply this by in order to get 2? What times 1 is 2? Oh, I didn't hear you. All right. How many CUs? There's a 3 in front. How many CUs? How many CUs? How can we fix that? In order to fix the CLs, we had to put a 3 in front. I know. We're adding the line. Is it on yours? Is there a line on yours? No? Okay, there should be a line on yours. So 3 times 2 is 6. 2 times 3 is 6. All right. This is hard. Not really. All metals are what phase except for mercury? Solid, liquid, or gas. All metals are what phase except for mercury? Solid. Mercury is what? Liquid. All right, now, Austin, do look up Al and Cl on your chart. All right. You have a worksheet. Call me. The first 5 are easy. All you do is look on the chart. The next, you're looking on the chart and you're having to balance. So call me if you get stuck. I was able to help 3 people that were confused with balancing. After they did this worksheet, they had much more confidence. So call me over when you need help.